Ladies and gentlemen, welcome. This is our sixth seminar of 4ST601 Statistics in English. Today we will start with one regression model which was not solved on the previous seminar number 5. We will start with regression plane and multiple regression model. There is a data set. It says the influence of two different types of advertisement on new sales of new CD. We obtain the following data. So we have here dependent variable sales, yes, in 1,000 Czech crowns. So you are selling CD. And you would like to sell a lot of CDs, yeah? So you need advertisement on your CD. So it's possible to advertise in radio and television, and it's possible to advertise in press. So we have here two independent, two explanatory variables, yes, costs on advertisement in radio and television and in press. What can we do? Calculate the parameters of regression plane that is describing the dependence of sales. Sales are dependent variable, yes, on the amount of costs on advertisement in radio and television, independent variable x1, and on the amount of costs on advertisement in press, independent variable, explanatory variable x2, yes? And we would like to characterize the strength of the dependence. So, regression plane, it's possible to calculate manually or in Excel. I know how to solve this manually, yes? Because I know the formulas, but you don't know, because you don't have formulas in formula sheet, yes? So it's necessary to use Microsoft Excel, least squares method in Microsoft Excel for the solving of this example. So if you remember, we need to install special add-in, yes? Because today I opened this Microsoft Excel for the first time. So if you click on data leave, you can see that I don't have installed toolpath analysis, yes, in the right top corner of this screen. So what's necessary? It's necessary to click on File button, find Options. So I will do this. I will click on File button, and there we have Options, yes, on the bottom, Options. And in this window, you have here add-ins. So please click here, add-ins, and you will see here in this table, Manage Excel add-ins, and there is Go button with 3 dots. So again, we will click on this Go button with 3 dots. And in the small table, we will select Analysis Toolpath. So please select this Analysis Toolpath. OK. And on the data leaf, yes, data leaf, you will see Data Analysis in the right top corner. So please select Data Analysis, find Regression, yes, and we will select the data set. So Data Analysis, please wait a second, you will see this small table and find here regression, OK. And now it's very easy. In the case of this regression plane, we are using one dependent variable. Input y range will be one column, sales, yes? We would like to explain the sales, yes, by costs on advertisement in radio and television, and advertisement in press. So this one column will be input y range. These two columns will be input X range, yes? Okay, so I will do this. Input Y range, sales, and input X range, costs, yes? Okay, and that's all, yes? You can click on OK, and on new worksheet we will see the results, yes? So, okay, there is a new sheet, so please, I will zoom what is necessary. This is necessary, okay, and I will delete what is not necessary. So these bounds are not necessary, okay. And I will use only 2 decimals, for example, yes? Okay, so here we have coefficients. So everything is ready. This is our regression plane. We have here coefficients, intercept B0, x variable 1, coefficient B1, and x variable 2, coefficient B2. I will check what was written, yes, in our example, and after I will move this output here on the left side, and I will use the whiteboard for writing. So I will check one more time what's written here. Calculate the parameters of regression plane that is describing the dependence of sales on the amount of costs on advertisement in radio and television and on the amount of costs on advertisement in press, yes? And characterize the strength of the dependence. So one more thing I will find here in this output. It will be good, for example, to find here r square and adjusted value of r square. Probably we will not compare this model with other one, yes? We just calculated the coefficients of this regression plane, and we would like to know how many variability, yes, how many variabilities explained by this model. So we can use classical R square because we have only one model, yes, without any comparison. So we can say that more than 83% of variability in the data set is explained by this model, yes. Adjusted R square will be used in the case that we will create another model explaining your sales of CD, yes. For example, with different number of coefficients, with different independent variables, etc. Yes. So that's all. Now I must use the whiteboard. Okay, so what is it? Regression plane according to your formulas. Yes. Y is equal to B0 plus B1 x1 plus B2 x2. Yes, this is a multiple regression model with 2 independent variables. The costs on advertisement in radio and television, yes, radio and television, and there we have advertisement in press, yes. What else is necessary? Dependent variable, I think the dependent variable is in thousands. Yes, in thousands, and the costs are also in thousands. Yes, so the units, thousands Czech crowns, and here also the units, thousands Czech crowns. Yes, so this is important. And now I will rewrite the regression coefficients. So y is equal to intercept 123.123 70 plus coefficient of x variable 1, 12.64, 12.64 x1 plus 18.86, 18.86 x2. So this is our model with calculated r square equal to 0.8324. 0.8324. Yes, so this was estimated, this was calculated in Microsoft Excel, and I will check what else we have to do. So please wait a second. What average increase of sales can be expected according to this model when the cost of advertisement in press increased by 5,000 Czech crowns, while the costs on advertisement in radio and television stay constant. So radio and television will be constant, and in press, advertisement in press, cost on advertisement increased by 5,000 Czech crowns. 5,000, yes? The units are already in thousands, so we will calculate this 18.86 times 5, yes, because the units are already in thousands, yes. So I will use calculator, and I will calculate 18.86 times 5. 94.3. So the result is that sales, yes, will be higher by, this is in thousands, 94,300 Czech crowns, yes. So if you increase your advertisement, the cost on advertisement in press, yes, by 5,000 Czech crowns, while the costs on advertisement in radio and television stay constant, you can expect the increasing of sales by 94,300 Czech crowns. Yes? So this is the calculation based on your model. Yes? And other calculation, other expectation of sales, so we can solve C, calculate according the model, the sales when there is spent on advertisement in radio and television. 40,000 Czech crowns, 40,000 Czech crowns will be used in radio and television advertisement, and 35,000 Czech crowns in press. So we must use this model. Y is equal to B0 123.70, yes, plus 12.64 times 40. The units, yes, are already in thousands, yes, plus 18.86 times 35. And the units are already in thousands. So I will use the calculator. 123.70 plus 12.64 times 40 plus 18.86 times 35. So the result is 1,289.4, but we know that this is in thousands, so the final interpretation will be 1,289,400 Czech crowns, yes? So this sales, yes, sales are equal to this value. So if we use this money, yes, and invest them to advertisement, in radio and television and in press, yes, 40,000 and 35,000 Czech crowns, you can expect, yes, that you also sell CDs, yes, with sales 1,289,400 Czech crowns. So this is the expectation of your sales, yes, on the basis of these conditions. Yes, so this was situation of regression plane with two independent variables. Yes. Also, it's possible to calculate another model with more variables. Yes, with more independent variables. Can you imagine, for example, another option, yes, where you can have advertisement. Yes? So also it's possible to extend this model B3, X3, but this is not our case. Yes? We have only two independent variables. Another simple example that is given the output from the regression analysis of the dependence of dependent variable y on the independent variable x. What it means, you can find here parameter estimates, yes, intercept, and there is variable x, so the slope of the regression line. Yes, this is classical regression line. Minus 34 point something is intercept, and slope is positive 9.1. Yes, and we would like to fill in missing data and speak about the results. You can see that a lot of values here are topics of week 11 of our academic semester, but we have here the table with calculated R square and adjusted R square, and you can see that R square is only 48%. Yes, if you remember our another examples, we had R square 80%, 90%, yes, so more than 48. So there is not enough explained variability. Yes. So what can we calculate now? What can we do? Only two things. Yes, we can calculate here only two things. And these things are sum of squares. Yes, here in this table, analysis of variance table, we have here calculated the total sum of squares and regression. Yes, regression or theoretical sum of squares is deleted, and also error sum of squares is deleted. Yes, so I will write here for you this source that this can be called regression. Yes, between group is regression, within group is error, and the total is total. Yes, so please check these cells. Yes, okay, so regression sum of squares is unknown, error sum of squares is unknown, we know R square and adjusted R square, so it's possible to calculate regression sum of squares, because we know that R square is a ratio of regression and total sum of squares. Yes, do you know this information? Check your formulas. Yes, where you have formulas here, where is our regression analysis here? R squared sum of squares, regression sum of squares, total. So when we multiply r squared and total sum of squares, we will receive regression sum of squares. So please do this. Let's do this. Here equal sign r squared multiplied by total sum of squares. Enter. Yes, you can see 20,653 point something. And now we know total sum of squares and the regression sum of squares. So total minus regression is error. Yes, so you can see equal sign this value minus this value. Enter, and you have here error sum of squares. And because error sum of squares, unexplained sum of squares is higher than explained theoretical regression sum of squares, this is the reason why r squared is so small, only 48%. Yes? So probably this model is not good, yes, and it will be good to improve it, yes. But about this we will speak later, probably in week 11. So for today, remember at least these operations. It will be good to start with some elementary characteristics of the time series, of the development in time. Yes, you know a lot of these characteristics because these characteristics are very simple, very often based on the difference, on the ratio, or classical arithmetical mean. Yes. So it's good to note what is the time series. We have here a variable y in time t. So again, observed variable, and there is a time. Yes, and we can observe the development, yes, of values in the time, as we have values y in time 1, y in time 2, y in time 3, yes, and we can finish, for example, y in time capital T. So the development of values of observed variable in time, this is the very simple definition of the time series, and according to your formulas we can denote the basic characteristic delta in time t calculated like simple difference y in time t minus y in time t minus 1 as absolute difference, yes, absolute increase or absolute decrease. Yes. If the result is positive, you have increasing in the time series. If this result is negative, yes, below 0, we have decreasing in the case of one observation, etc. Yes. So absolute difference, absolute increase or absolute decrease. We can calculate this also in relative way, yes, k in time t, coefficient of growth, yes, coefficient of growth calculated like a ratio y in time t divided by y in time t minus 1, yes, so this is another very simple characteristic, yes. So what else? Average absolute increase. Average absolute increase delta with stripe will be calculated, and in some type of literature, yes, you have this last observation denoted like Y with capital T, Mr. Hellman using N. Yes, because again N is our sample size. Yes, 1, 2, 3, 4, 5, 6, 7, etc. Yes, the size of the sample. Okay, so the calculation of this average characteristic, average absolute increase or average absolute decrease is again very easy. I can check the formulas and we have here y in time n minus y, 1 divided by n minus 1. So what is here? Last observation minus first observation, yes? Last observation minus first observation divided by sample size minus 1. So it's again very easy, yes? And the last important characteristic is average coefficient of growth. So K with stripe as average growth coefficient. So we will use the root n minus 1 root, yes, so there will be root n minus 1, yes, n minus 1 root from the ratio last observation and first observation. Yes, so there will be ratio yn divided by y1. Yes, so this is the last important characteristic, yes, and I have prepared a data set for you, so we will train these basic characteristic on the real data set in Microsoft Excel. Okay, so I hope that you are able to see these tables. We have here a development, yes, of the time series of gas production, historical annual time series. We have here 1, 2, 3, 4, 5, 6, only 6 observations. Yes, so n, the sample size is equal to 6, yes, like I wrote here. So 6 historical values of the production of gas in cubic meters. Yes, you can see production measured in cubic meters. The data was in the line. Yes, so I transformed this data set to column. Yes, because it's better for our calculation. So there you have the production, and you will calculate the simple first differences and the simple growth coefficients. Yes. So according to the formulas which I wrote on the whiteboard, we must start here with calculation. So please write here equal sign, and we will calculate this simple difference. Yes. Value in time t minus value in time t minus 1. We must start with calculation here, because when I start here on the position of year 1980, I don't have observation for year 1979, yes? So, if you calculate the first differences, Mr. Hellman said to you that we are losing one observation, yes? There, one observation must be omitted, there is not calculated, yes, because we must start here, like value in time t minus value in time t minus 1, and result. If the result is positive, we are increasing in cubic meters. If the result is negative, there is a decreasing in the development in cubic meters. Yeah? So it's very, very easy. You can copy the result, the values, yes, the formulas. You can copy the formulas. So for example, this value 102, what it means? Between year 1982 and 1983, the production of gas increased by 102 cubic meters. Yes? This value is 39, yes, on the last position. Between years 1984 and 1985, the production of gas increased by 39 cubic meters, etc. Yes? So this is interpretation. You can see that we don't have any negative value, so there was no decreasing during the time, yes? During all time. Growth coefficients. What is a growth coefficient? It's a relative number, yes? Relative number which can be above 1, below 1, or equal to 1. If the coefficient of growth is above 1, there is increasing, between here increasing, yes? And we can interpret this increasing in percent, yes? If the value, the result is below 1, yes, there is a between here decreasing. And again, we can interpret this decrease in percent. So I will show this to you and I will interpret, I don't know, two results, yes? So you can write here equal sign and this value divided by this value, yes? Be very careful. Very often mistake done by students is that students calculate the ratio from these first differences, yes? It will be wrong, yes? We must calculate the ratio from original data set. So y in time t divided by y in time t minus 1, yes? Divided by previous value. So calculate this ratio and you can copy the formulas, yes, to the end, and you can see that all values, yes, all values which we have here are above 1. Yes, so, for example, write the first value, 1.06, yes. What it means? It means that between year 1980 and 1981, the production of gas increased by 6%. Yes. For example, this value 1.051. Between years 1983 and 1984, the production of gas increased by 5.1%. Yes. Can you imagine the result of decreasing, for example, decreasing by 5%? Result will be 0.95, yes? 0.950 will be decreasing by 5%, etc. Yes, it's a simple interpretation of a relative number. We can move this table, yes, and we are able to calculate mean first difference, yes, the mean of the first differences. It means how many more gas is produced each year. Yes? So the mean calculated from the time series. Okay, mean first difference. Mean first difference. Do you remember this delta? Yes, this delta with stripe. So last observation minus first observation divided by, and in denominator is written n minus 1. We know that we have 6 observations, so in denominator will be 6 minus 1. Yes? So please do this. Calculate this mean first difference. Equal sign and in nominator. What is in nominator? The last value minus first value. Yes. So this is nominator. Last value minus first value divided by, and in denominator is 6 minus 1. So please, right here, divided by 6 minus 1. Yes. And you must see value 64.8. It's in cubic meters, yes, and there is written as the response how many more gas is produced each year. So it's average increasing every year. Every year you produce more gas more by 64.8 cubic meters. Yes, so this is average increasing every year. Yes, the disadvantage of this mean forest difference is that it doesn't matter, as does not take into account, it doesn't take into account the development inside, inside the time series. You could see that we calculated this value only like a difference between last and first value, without influence the values in the middle. Yes? So this is disadvantage of this coefficient. And in the same way, we can calculate mean growth coefficient. So you can see here on the whiteboard, I wrote K with stripe, mean growth coefficient. So it's n-1 root, from the ratio of last observation and first observation. So I will write two parentheses this ratio. So first I will write here equals sign. I will open the parenthesis and the ratio, this value divided by this value, close. So this is the ratio, and now the root. How can we calculate n-1 root? N is 6 minus 1, so fifth root. We will use power function. Which is on the keyboard. On number 6. English keyboard, shift and number 6. And there is a hat. You will see the hat, and it's a power function. So we will power this ratio by 1 divided by 5. And this will be the fifth root. So please use power function. Can you see the hat? And this will be powered by 1 divided by 5. 1 divided by 5 in parentheses. So please click on OK. I hope that you are able to do this, or you can do this to the calculator. On the calculator you have also the hat, the power function. Result is above 1.046. What it means? It means that you produced more gas every year. Every year you produced more gas by 4.6%. So this is average increasing for every year. Every year you are producing more gas, more by 4.6%. If the result is below 1, you will produce less. Every year decreasing, but we have increasing. Okay, we can calculate some simple average from this development. I will check the formulas which you have here. So I show to you this delta and this delta with stripe. I show to you this K and this K with stripe. And we have here some averages. This first mean can be used for the situation for the flow time series. For example, for our time series, about the development of gas production. We have here the flow time series. So it's possible to use this one mean, this simple mean, which will be used on our annual time series. And after we have here another one, this general formula, this general equation for calculation of mean, which will be used in next example for the calculation of average in the case that we know, yes, we know the state, we know the value at the beginning, for example, on the particular months, on the particular quarter, yes, etc. So if we know, yes, the value at the beginning, yes, some observation. So in the case that it's not flow time series, like in the case of gas production, yes, it's necessary to use this second one, yes. Okay, so, but now we have only flow time series, so I will use this first one, where you can see it's a simple summation of all values in our time series, divided by number of observation, yes. So, I will use this Excel, yes, and for example, here, calculate the arithmetic mean of this flow time series, yes. It's necessary to calculate summation of production, yes, in cubic meters, divided by number of observation. In our situation, we have 6 observations, so please calculate here equal sign summation, sum at all numbers in a range of cells, yes, summation of these values divided by, and we can write here 6, yes, or we can use the function. We can use the function count, yes. I will use count function divided by count. Counts the number of cells in a range that contain numbers, yes. So I will use this function count, and you can see I will count the number of values, yes, and you will see that there will be average annual production, yes, average annual production, arithmetic mean of this flow time series. Enter, and the result is 1453, yes, 1453 cubic meters. Average production, average annual production, yes. Okay, so this can be used for the situation of flow time series, and I will show to you different situation. So the table below shows the number of seasonal employees, temporary workers, yes, in the car factory. The numbers are valid on the first day of the particular month, yes. So this is not the flow time series, yes. The data, yes, are valid on the first day of the particular month, so the 1st of January, on the 1st of February, on the 1st of March, etc. And we would like to calculate the average number of these workers, yes, the mean over the year, yes, average number of the workers. So it's necessary to write here the number of days, yes, in the particular months, but mainly we are using for February 28, yes. So I will write here the number of days. Yes, so 31, 28, 31, 30, 31, and there we have June 30, 2 times 31, yes, during the holidays, during July and August, 31, 31, and after again we are changing 30, 31, 30, 31. Yes, so the number of days. And now we will use the formula which was written here. Yes. Okay, so y in time t time t equal to 1 plus y in time t equal to 2. So first observation plus second observation divided by 2, yes, weighted by number of days. And we will continue, yes. So we will calculate these, we will calculate these partial results here. Equal sign, I will open parenthesis. This value plus this value close divided by 2, weighted by number of days. Yes? So this is the same. Maybe again I will zoom this table. So please, I will copy this, escape. I will zoom this table. It will be better. And I will write these formulas here, yes? So, this value plus this value, it's a summation divided by 2, weighted by number of days, yes? And we can copy these formulas, yes, to the end, and you will see that on the last position here, yes, we will calculate the summation of 143, 130, yes, divided by 2, weighted by 30 days, yes. This last position, this last value of number of days will not be used, yes, in our calculation. So you can check this until here. Yes, you can see we must stop here, yes, because we don't have other observation, yes, we don't have observation on the 1st January of the next year, yes. So this is the end of the partial calculations. We must calculate the summation, the sum of these values, yes, and after we will divide this summation by number of days. Number of days in January, February, March, April, May, June, July, August, September, October, and November. The last position, the last observation of the number of days is dn-1. Yes? Do you know, do you remember this formula? Do you remember this formula? Yes. Here you have d1, d2, d3 until dn-1. Yes. So I will calculate, for example, here the summation, equal sign, summation of these values, yes, divided by, and there will be 31 plus 28 plus 31 plus 30 plus 31 plus 30 plus 31 plus 31 plus 30 plus 31 plus 30. Yes, or you can write summation of these values without the last one. Yes, so it will be maybe better. It will be better to calculate divided summation of these days. Yes. Okay, and there is the average. There is the mean. Almost 147. Yes. If I use 0 decimals, the average number. Yes. The average number of annual workers. Yes. Is 147 employees. Yes, this is the mean calculated on the basis of this data set when we had data actual on the 1st of January, February, yes, on the 1st of particular months. Yes, so we had to use the number of days, the weights. Yes. We have here another example. See the sheet 2. Yes, I downloaded for you a sheet from Czech Statistical Office. Yes, there are vital statistics of the Czech Republic, the real data set from year 1992 to year 2016. Yes, about monthly figures. Published by Czech Statistical Office. So the real data set downloaded from the web pages of Czech Statistical Office. So we will use this real data. We will use monthly published data about net migration in the Czech Republic between year 2015 and 2016. So I will show to you this data set, yes, just for illustration. You can see this at home. You can see that this table is bilingual, yes, in Czech and English language. So we have here vital statistics of the Czech Republic, absolute monthly figures, yes, and you can see that we have here mid-period population, marriages, divorces, live births, etc. Yes, and I said that we will use net migration, yes, net migration, and you can see that you have here in yellow color, yes, in yellow color denoted some values, yes, monthly observations, monthly published data. So we'll use 2 years, year 2015 and 2016, monthly published, so 2 times 12, it means 24 observation, yes. So I copied these values, yeah, this observation for you to our data set here. This is copied from the previous sheet. Yes, you can see year 2015, January, February, March, April, May, etc. Yes, and the values. Net migration, yes, is a difference between immigrants and emigrants. Yes. If the value is positive, yes, you have in the country increasing of number of inhabitants. If the value is negative, yes, you have decreasing of inhabitants in the sense of migration. Yes, so you can see the values are positive in year 2015 and 2016, yes, and we have written some tasks, yes. What's written here, transform this time series, monthly time series, to quarterly time series, yes. So we will transform monthly published data to quarterly data, and we know that our observed variable, net migration, yes, is measured in which units? In people, yes. We have here people. So it's very easy to transform this monthly time series to quarterly time series, because we know that January, February and March is the first quarter of the particular year, April, May and June is the second quarter of the particular year, etc. Yes, so we can calculate a simple summation, simple summation of 3 values, and we have first quarter. Next summation of next 3 values is the second quarter, etc., etc. So you have here, for example, October, November and December, 3 values, and summation of these 3 values will be the 4th quarter of year 2016. Yeah? So this will be very easy. And after, we will smooth the quarterly time series by appropriate moving averages. Yes? And we will write down on the paper only the first 4 calculated values of these averages. Yes? So we will do in Excel the transformation of this time series to quarterly time series. After, I will rewrite this data set, quarterly data set, on the whiteboard, and I will calculate the moving averages on the whiteboard, yes, for you. So the transformation, yes, please check the table. I will move here, yes. I hope that you are able to see this, but it's very easy, yes. first quarter of year 2015 is a summation of value 1384, 1461, 1544. Yes, and the result is in people, yes, persons. Okay, so summation of these three values, close enter. I will write it here, okay, and we can continue. Equal sign, summation of April, May, June. Yes. April, May and June is the result for the second quarter. After July, August, September, yes, is the third quarter. So there we have result 3102, equal sign, summation, July, August, September. And finally, equal sign, summation, October, November, December. Yes? So this is transformed first year, yes, year 2015, to quarterly data set. And now the same with year 2016. Yes, so please, I will move this table here and we will calculate it here. Equal sign, summation, January, February, March. Yes, equal sign, summation, April, May, June. Equal sign, summation, July, August, September, and equal sign, summation, October, November, December. Yes, so there is a table, yes, with quarterly data set. I calculated just summation of 3 months. Yes, and now I will rewrite this table on the whiteboard and I will calculate for you the moving averages. Because this is quarterly time series, I will use moving average with the length 4. Okay, so you can see that I rewrite it, the data set, yes, on the whiteboard, and you can see that here in the first part there is the year 2015, and there in the case of second part there is the year 2016, yes, and this is the time series, quarterly time series, and I would like to calculate, I would like to smooth this time series by appropriate moving average. Because this is quarterly time series, we must use moving average with the length 4. Yes, if you want to smooth monthly time series, it's necessary to use moving averages with the length 12, etc. Yes, so the periodicity, yes, the frequency of the time series is also the length of the appropriate moving average. Yes. So we must calculate moving average with the length 4. It's very easy. Y in time 1 plus y in time 2 plus y in time 3 plus y in time 4. Yes, divided by 4. This is simple moving average with the length 4, but there is a problem in this type of time series, that these time series are very often with even frequency. Yes, there are two situations. We can have even frequency and odd frequency. Yes. In the case that we have odd frequency, yes, it's easy because we are able to write the result on the position of median. Yes, if you have observation y in time 1, y in time 2, y in time 3, y in time 4, and y in time 5. And you will calculate moving average with length 5. Yes, because we have here 5 observations. The result is placed on the position of median. Yes, so on the position y3. But now we have even length. Yes, even length. So there is no place for the calculation of result, yes, for the writing the result. So this is not the end, yes, we will calculate these averages and we will have to continue with some other calculation, yes. So I will delete this because we don't have odd length, yes, we have even length, yes, this is even in our situation. So we will calculate the first result, for example, here on this position, yes, and the result will be calculated like 4,389 plus 3,102 plus 2,651 plus 5,835. Yes, and this will be divided by 4, yes, according to this formula. So this will be the first result, yes, and we will continue, yes, we will calculate another partial result here, yes, and on this position we will calculate the value from values 3,102 plus 2,651 plus 5,835, and we are moving to another year, 5,293, yes. And this will be also divided by 4, yes, and we will continue as here, and we will continue here, and we will continue here, and we will this is from this 1, 2, 3, 4, and this will be end. We cannot calculate the result as on this position because we don't have observation for the first quarter of year 2017, yes, etc., etc. So you can see maybe it will be good to use a different color. Yes, you can see that we will calculate here the summation of these 4 values. Result will be here, and we are moving, yes, we are moving here, yes, and there will be another result, and after again we are moving, yes, here, there will be another result, and again we are moving, yes, there will be another result, yes, and finally you can see from these last, yes, from these last 4 values will be calculated this value, yes. So I hope that it's clear, yes, and I will calculate these partial results for you, yes. So for 4,3,8,9 plus 3,1,0,2 plus 2,6,5,1 plus 5,8,3,5 divided by 4, and the result here should be 3,994.25. Yes, and we will move another 4 values. Yes, 3,1,0,2 plus 2,6,5,1 plus 5,8,3,5 plus 5,2,9,3 divided by 4. 4,2,20.25. Yes, and we can continue. This value, this value, this value, this value. Yes, 2,6,5,1 plus 5,8,3,5 plus 5,2,9,3 plus 4,9,7,3 divided by 4. 4,688, and we can move. Yes, we can move this value, this value, this value, this value, this value, this value, and this value. So I must start with 5,835 plus 5,293 plus 4,973 plus 3,610. Yes, divided by 4. The result should be 4,927.75. Yes, and finally last 4 values. Yes, it's difficult, we must be careful. Yes, 5,293 plus 4,973 plus 3,610 plus 6,188 divided by 4. 5,016. Yes. Okay, so this is only the first part. Yes, because I already said that this sample is even. So now we must continue. Yes, we must continue. Why? Because this value must be placed here. Yes, here must be calculated the first result. So after we do this, we must calculate also the mean, the moving average. Yes, from 2 neighborhood values. Yes, so 3,994.25 plus 4,220.25 divided by 2 is equal, and this will be first final result. Yes, first final result. So please, 3,994.25 plus 4,220.25 divided by 2, and the result is 4,107.25. Yes, so this is the first final result. Yes, this is not the end, this is the first value of moving average. This is the first value of moving average, and you can continue. Yes, you can continue another 2 values. Yes, 4,220.25 plus 4,688 divided by 2 yes, equals sign, and the result 4220.25 plus 4688, and they're divided by 2. 4,454.125. Yes, so this is the second final result. Yes, and we can continue. 4688 plus 4927.75. This will be divided by 2. Yes, and we will reach the third final result. 4688 plus 4927.75 divided by 2. Yes, 4807. 4807.875, and finally last two possible values, 4927.75 plus 5016 divided by 2 is equal to 4927.75 plus 5016 divided by 2. 4971.875. Oof, I hope that I calculated everything correctly. Yes, so this is the value which should be placed here. Yes, and this is the value which should be placed here. Yes, and this is the value which should be placed here. Yes, and this is the value which should be placed here. Yes, and 1, 2, 3, 4. This is because we have even sample. Yes, there is no median. There is no median position for writing of results. Yes, so we had to use 4 values. This is not the final result because we cannot place this value to the middle. Yes, so we have to calculate also the moving average with the length 2. We have to calculate the mean from 2 neighborhood values. Yes, and after we have the final results of final moving averages with the length 4. Yes. In the case of odd frequency, yes, 3, 5, 7, 9, 11, etc. The situation is more easy because after you calculate this first step is the final result. Yes, but many of time series require the even length. Yes. We will return here to this section of formulas and we'll try to calculate the base and the chain indices, yes, again on the real data set, and we'll try to interpret the calculated results. Simple base index, yes, is calculated like value y in time t divided by fixed value. That is written y1, yes, because in these formulas Mr. Hellman expected that the first observation, as in our data set, will be the base. Yes, so we can do this, we can calculate it with the base set on the first observation, and we can set any other observation like the base. Yes? So it's possible to calculate this index like value in time t divided by the base. Yes? And the base is still the same. We can compare this with chain indices. Yes? And you can see that the chain index is very easy because it's calculated like y in time t divided by value y in time t minus 1. So it's classical coefficient of growth, yes? Coefficient of growth and the chain index is the same, yes? So we will use the real data set and we will calculate these indices. I have here this real table, yes, again from sheet 2 where we have vital statistics of the Czech Republic published by the Czech Statistical Office. I copied this table with data for year 2016, yes, monthly published data with monthly frequencies about marriages and divorces, yes. So use monthly published data about marriages and divorces in the Czech Republic in year 2016, published by the Czech Statistical Office, calculate base indices and chain indices. You can see that we have prepared here a table where the base, yes, is set on January, and here in this sentence is written also the base observation set on June. So I will write here set on January, the base observation set on January and June, yes, and we will compare the results. This is our deal, yes, the base. It's not necessary to have the base only on the first observation, yes. We can make a deal, yes, with another base, and my deal with you is, for example, June, yes. We will try it. We will train it and try it. Okay, and chain, yeah? So base with the base January, with the base June, yes, and chain the coefficient of growth, yes, and the same for divorces. So I will move this table, yes, and you can see that it's visible everything, yes. Okay. So the base will be set on January. We must calculate the index like value in time t divided by first value, yes? So value on January. So please write here equal sign this value divided by this value. And because our deal is that the base will be January, I will use function 4 button on the keyboard, and I will lock the denominator, yes, please lock the cell by function 4, F4 button. Can you see the dollars? Yes, we can see the dollars. This cell is locked, yes. And if you click enter, you can copy, yes, you can copy these values, these calculations to the end, and you can see that there is on the last position calculated a ratio between this December and January, yes. The base on January, set on January for the case of marriages, yes, it's not good because during the winter, yes, for example during January we don't have a lot of marriages. You can see that there is the smallest number in the table, so it's not comfortable for interpretation these large indices. Yes, you can see this value, for example, in December 1.243. We are able to interpret this. Yes, in comparison. Yes, in comparison with January. Yes, in December increased the number of marriages by 24.3%. Yes, in December increased the number of marriages by 24.3% in comparison with January. Yes, with the base. Here in November, yes, increased the number of marriages by 79.5% in comparison with January, etc., etc. Yes, so this is easy for interpretation, and these values are complicated because there is a lot of 100%, increase. Yes, in comparison with January. So this is the reason why I wrote here that we'll also try to set the base, for example, on June. Yes, so June will be the base. Okay, so please, we can start calculate here. Yes, we can start calculate here, because the ratio will be marriages on January as divided by marriages in June, and again we will use function 4. Yes, so everything, yes, will be compared with June. Yes, the June is the base. Okay. So we can calculate this, yes, and you can see that this is better for interpretation. Maybe I forgot to calculate this first value. Can you see? There is 1.000 because we calculated 9,165 divided by 9,165. Yes, that is the ratio between June and June. So also it's possible, yes, to calculate here the ratio marriages in January and marriages in January. Yes, 1.000. Yes, it's possible. Yes, value 1. If you see the value 1, you can identify, for example, the base, or you can identify that nothing changed. Yes. Okay. So, for example, this value, yes, 0.888. This is calculated for July. Yes, and the base is June. So. In July, yes, on July in comparison with June, decreased the number of marriages, and this number decreased by 11.2. Am I right? 11.2%. Yes, 11.2, because it's below 1. This value, for example, 0.828, yes, what is it? It's August, yes. In August, in comparison, yes, in August, in comparison with June as the base, yes, there decreased the number of marriages, yes, and with comparison with June, it decreased by 17.2%. Yes, 17.2%. Is there some increasing? No, because the June has the largest value. Yes, this value, for example, on April. Yes, on April with comparison with June, decreased the number of marriages, and the number decreased by 55.4%. 55.4%. Yes? Am I right? Yes. 55.4%. So there we have base indices. Yes? And chain indices is very easy because you can see that this is calculated like simple ratio, this value and this value. Yes? These two values without fixation. Yes? There is no fixation of denominator. So please click enter. And interpretation is very easy because it's a comparison with previous value. Yes? On February, increased the number of marriages with comparison with January, in comparison with January by 25.5%. On March, yes, increased the number of marriages by 11.6% in comparison with February, etc., etc. Yes? So the result is increase or decrease in comparison with the previous months. Yes? So this is the chain index. And really, there we don't have yes, the first value. The first value is really omitted. Yes. Okay. So base indices for divorces. Yes. January will be the base. Yes. So again, it's possible to calculate something here because the result will be 1. Yes, base indices, January is the base, so there will be value 1 and everything else will be compared with January. So divorces. We can write here divorces in January divided by divorces in January, but the denominator must be fixed. Can you see dollars? I used function 4, yes, function 4, so it's fixed. Okay, so please click on enter, you can see 1, yes, and now check. If you copy this formula, you can see that we are dividing May with January. January is fixed, yes, because January is a base. Okay. So I will finish this and you can see, for example, this value, yes, 1.052. What is it? There is increasing on September, yes, on September the number of divorces increased in comparison with January, increased by 5.2%. in comparison with January, yes? And on August, number of divorces decreased by 3.9% in comparison with January, etc., etc., yes? So again, you can set any base you want, any base you require, yes? So here I will calculate the ratio January divorces and what's written here, June divorces, and June divorces will be fixed, yes? Function 4, F4 button dollars, yes? You can see the cell is fixed, so please calculate everything. On the position of June, you will see value 1 because the June is the base, yes? June is the base. And again, some interpretation. On February, number of divorces decreased, yes? We had a smaller amount of divorces smaller by 14.4%. 14.4%, yes, in comparison with June, yes. The value, for example, here, yes, on November, yes, in November we have a smaller number, yes, of divorces. It decreased, number of divorces decreased by 18.9% in comparison with June, etc., etc. Yeah? So we set different base. And finally, chain indices for divorces. So again, we will lose one observation because we don't have December from the previous year. Yes? So there will be nothing. And here we can calculate the ratio. Divorces in time t divided by divorces in time t minus 1. It's classical coefficient of growth, yes? The comparison is between the particular months, yes? So we can select any value. For example, this value 1.023. 1.023, it's increasing of divorces by 2.3% in comparison with February. It's increasing in March in comparison with February, yes, etc., etc. So you can see that the base and chain indices are very easy. Okay, ladies and gentlemen, so this is the end. This is the end of our 6th seminar. Next week we will probably continue with time series decomposition. Yes, we must solve one very, very large example with a lot of steps. Yes, so this will be probably the first example of the next seminar number 7. So I hope that everything was clear. I wish you have a nice day. I will see you next week, and that's all. So bye bye.